For section 8.5, we're going to look at some more multiplication and division with radical expressions. Let's look at this first problem. It looks like we've got a binomial times a binomial, but inside of those binomials are radicals. Now you're going to follow the same procedures that we learned last semester, and you're going to multiply everything in the first set of parentheses times everything in the second set of parentheses. You're just going to take it slow and remember how we multiply radicals. So let's start with the 7. 7 times the square root of 5 is 7 root 5. Now I got to go back and I got to take that 7 times that positive root 2. Well, 7 times a positive root 2 is a positive 7 root 2. Be careful, the 7's on the outside, the 2 is on the inside. They need to stay that way. Now I'm not quite done. I got to go back and do my negative root 3. So I'm going to take negative root 3 times positive root 5. Well, negative root 3 times positive root 5 is negative root 15. Since they're both under the radical, we can go ahead and multiply that. Now I'm going to go back again and take negative root 3 times positive root 2, giving me negative root 6. Now I know this answer looks silly, but at this point we can't do anything. Remember, when you add and subtract radicals, you have to have a like radicand, and we don't have any like radicands, which means we can't put any of these terms together, meaning this, as strange as it may look, is our final answer. Let's take a look at this problem. Our typical response is to distribute that 2n. However, if you remember from last semester, we can't do that due to this minus sign right here. So what we actually have to do in a problem like this is write it out twice and multiply it the long way. So when I write it out, it's going to look similar to this. Root 7 times root 7 is root 49. Root 7 times negative root 3 is negative 3 root 7, keeping them separate. Now I got to go back and do everything with the negative 3, so negative 3 times negative root 7, or excuse me, negative 3 times root 7 is negative 3 root 7 again. And then negative 3 times negative 3 is positive 9. Now what we're going to start looking at here is if we can clean this up. And I noticed two things. First of all, I noticed that the square root of 49 is actually 7. I've got a 7 and I've got a positive 9. I can put 7 and positive 9 together at 16. I also noticed that I have two like radicands here. They both have a root 7, and since they both have a root 7, it's okay for me to go ahead and put them together, making this answer a little more simplified. 16 minus 6 root 7. For our final problem today, I want to look at a division problem when you've got a quantity. A few sections ago, we took notes on how to get rid of a root when there's just a root in the bottom, but now what we're going to do is look at what you do when there's a quantity in the bottom. So when you have a quantity in a problem and it's in the denominator, you still have to get rid of the root, except however I can't just multiply by root 3 like we did when it was just one number in the bottom. We actually have to multiply by something called the conjugate. The conjugate is the exact same numbers and symbols, but instead of a minus, I'm going to put a plus. So in other words, a conjugate is the exact same thing, just with the sign changed. Now, we got to do 4 plus root 3 over 4 plus root 3. Remember how we talked about this represents a 1, and so we're really multiplying by a 1 and not changing it. Now, we're going to take this piece by piece because this is going to be done a different way. I'm going to distribute the 5 in. So that's going to be 20 plus 5 root 3. Now on the bottom, I'm going to actually have to distribute and FOIL out the long way, like I did on the last few. So 4 times 4 is 16. 4 times positive root 3 is positive 4 root 3. Now I got to go back and do it with the negative. Negative 4 root 3 and then negative root 9. Now I know what you're thinking. You're thinking, gee, Ms. Chapeau, we did all that multiplying to get rid of the roots in the bottom, and we didn't get rid of any of the roots in the bottom. But check it out, you actually did. Positive root 3 and negative root 3 cancel. The square root of 9 is technically 3, so what you end up with is 16 minus 3, or 13 in the denominator. You did get rid of the roots, which is what we wanted. Now in the top, everything looks great in the numerator. However, I need to factor it. Remember, we want to always try to factor our rationals out as far as we can, which we learned in section 7. So I'm going to factor out that GCF of a 5 and leave this at 5 times the quantity 4 plus root 3 over 13.